Today we're going to take a field trip along Rock Creek. So we're going to be in the headwater areas of Rock Creek where it's dammed here at Lake Needwood. And this was dammed to slow down floodwaters. And then we're going to go down into the tributaries of Rock Creek where you can see some of the water pollution issues that are there with runoff and storm drain pipes. We're also going to see restoration activities along the way to tie it into last week's field trip. And we're gonna go further down. This is where I live, right about here at the park boundary, the national park boundary, Rock Creek National Park. And then we're gonna trace the stream as it goes through the park to see how the water quality changes going from these suburban, urban areas into the national park and then out by the zoo, which is in Washington, D.C. So I hope you enjoy this field trip. Needwood. And this drains suburban Rockville and a bunch of areas that are what are called ex-urban, so they're not fully developed. And so there are septic systems that basically release nitrogen and phosphorus into the groundwater below the rooting zone that can enter streams and creeks that go into Rock Creek tributaries. There are also some sewage pipes, and these sewage pipes can leak and then also enter the creek as well, releasing nitrogen and phosphorus, nutrients which stimulate the growth of algae and bacteria. And then there are home lawns which are fertilized with large lots where that fertilizer also adds nitrogen and phosphorus. And then finally air pollution can also release nitrogen. The water goes into into Rock Creek, and then what it does is it goes underneath this pipe and then it goes into Lake Needwood itself. Lake Needwood isn't a natural lake, but it has the characteristics of a natural lake. The glaciers didn't extend this far down south, and so the lakes in Maryland are actually reservoirs, so they're made from damming. And so some of the natural characteristics of a lake are that it has what's called a photic zone, which is where the light penetrates the upper part of the lake and algae and bacteria can grow. You can see that the water is kind of bluish green here. There's actually algae problems where there's too much algae in the summer months, and sometimes the lake is closed down for recreation because of the blooms of microcystis, which is a toxic algae that grows during the summer. It's a blue-green algae, and it does what's called nitrogen fixation. So it's able to fix nitrogen from the atmosphere to bring it into the water because nitrogen's an important limiting nutrient, and then it gets phosphorus from the water. And it actually produces a neurotoxin which can be dangerous to people. So water quality issues start up here in the headwaters and this dammed reservoir up in Rock Creek. Along Rock Creek, the different forms of infrastructure aren't just roadways, but there are also bridges. For example, the Purple Line is now being built, and you can see here that the stream has been put into a temporary channel, where they've constricted the channel by putting up these pipes for overflows and then gravel to constrict the channel so that they can do construction. And so if you remember our lecture on the continuity equation, when you change the cross-sectional area of the stream, it affects the velocity. So the velocity of the water is moving a little bit faster through this constricted area. This is just the example of how the continuity equation applies to streams and rivers and can increase the velocity of water and sometimes the transport of pollutants further downstream. When there's floods, what happens is it scours the stream banks and then these trees fall in and there's a lot of erosion. So what they've done to this stream is that they've put a bunch of rocks to armor the stream because there's a road that's right next to it. That's a road that leads up to my house. And they've also reconnected the stream with the floodplain. So you can see this floodplain area where the water, when it floods, it'll spread out and then it's washed down a bunch of trees still. And so this was a stream restoration on a small tributary of Rock Creek. But that's what it looks like, and those are some of the common things that we do with floods. And then you can see all the trees that get washed away and the armoring that goes on in the banks. And that's to basically protect infrastructure that's all along these stream channels like sewer lines and to protect the downstream areas as well. Take a look at this. Oftentimes we think about water pollution starting in streams, but look at this storm drain right here. There's water that's flowing right here. You can hear it in the background. Maybe you can see it if I can crawl in there a little bit. Can you see that? That stream of water? Take a look outside. There's no rain. It's a sunny day, right? And so the question is, where's that water coming from? Some of it's coming from groundwater and leaky pipes. And so there's sometimes perennial flow that's happening underneath our feet that's going into storm drains and into streams. And that's kind of cool, you know, that there's not even any rain and there's still water always flowing from the ground, from pollution, from leaks entering streams. There's runoff that comes from the yard, and it can form a little head cut where a little stream is coming and forming, and you can see all these little pipes coming as well. There's a trail that goes in, and then there's a storm drain that leads into this tributary. And take a look at the water. What color does the water look like? Looks orange. And that orange color is from iron that comes out in the groundwater into the storm drain pipe. And when it comes out into the storm drain pipe, that iron gets dissolved, and because there's low oxygen conditions, and then when it comes into contact with oxygen, it actually becomes oxidized, and that oxidized iron is what you see here. Now if you look at it gives it that rusty color. And when Goldie was a puppy, he was originally black, but he used to love to play in this water, and then somehow he turned this rusty orange color. Maybe Chen Ching and Kelsey can ask you that as a true-false question on your quiz. Okay, anyway, if you look at the water, there's also this filmy color as well. And what that is that there's a lot of leaves that have fallen into the storm drain. And when they come out and when they fall into the stream, they lose their cuticle, and then that wax builds up on the surface, and so that contributes to this oily sheen. Also, sometimes there's motor oils and grease that are on roads that can actually wash into streams as well, and then that can contribute to that kind of oily sheen. So oil and water don't mix, so it's basically floating here at the top because they have different densities. And then when you look, you also see that there's foam, and there's also, it looks like there's microbial mats. And these are bacteria that have evolved to, you know, basically with the iron cycle and the organic matter that's at the top of the stream. One way to slow the flow of water during storms and also help purify the water is to do what's called regenerative stormwater conveyance, or actually come up with these treatment trains of different stormwater cells. And this is a tributary of Rock Creek. It's by the Beltway. You can hear the Beltway traffic in the background. And these are different cells that the water goes through as it comes from a road, in this case Beach Drive, and the stormwater goes through these different cells, and it's retained, and then that gives time for the water to come in contact with the sediments, the muck at the bottom of the cells where there are plants, and they can take up and transform some of these nutrients and metals and chemical cocktails. And I thought I'd show you our old friend Goldie. Goldie, sit. He's not listening. He's eating some grass right now, but I thought I'd show him to you in case you forgot him. All right, bye for now. As water travels through Rock Creek Park, it takes a break from receiving inputs of runoff from impervious surfaces, although Rock Creek Park does have its fair share of storm drains still entering the stream, and sewer lines still run along the length of the creek as well. But you can see that the areas next to the stream are riparian zones that are full of trees, although the trees do fall in from increased erosion, and there are roads that travel along the creek along with running trails and bike paths. But these riparian zones help filter out some of the pollutants in the groundwater that enter the stream, such as nitrogen and phosphorus. And also the surface of the riparian zone can trap metals and organic contaminants with the vegetation. And so this water flows from some of the areas of Chevy Chase and upper parts of Chevy Chase before it gets into the park, and then outstream, the downflow area that flows out into the National Zoo. As we leave Rock Creek Park, you can see that the stream and the valley share the same space as major roads, which are right next to it. And so what people have done over the years is they've armored the stream bank to contain the floods, which we talked about in the previous lecture. What this does from a water quality perspective is as you get into the city, all the storm drains and the storm waters are more efficiently transported to the stream along with all the pollutants with them. And so when you channelize a stream like this, not only do you change the flood risks that go downstream, but you also magnify and amplify the contaminant pulses along with those floods. And so there's a temporary change in water quality we found when Rock Creek goes through the national park, but when you go further into DC, you start to resume and problems in water quality and see some of the other effects that you see upstream closer to Rockville and other areas. And you can see this attention pathway is currently closed due to flood damage. So this area does flood. And I just thought I'd take you on a bike tour of Rock Creek and some of its water quality issues.